This vial is filled with crystal violet. While you might be intrigued by its name, I mean, come on, crystal violet. It's actually a pretty common dye, and you might even use it every day. Crystal violet is one of the compounds used in black ink, used in ballpoint pens or in printer inks. It's also used to dye textile, and many famous painters use crystal violet, such as Van Gogh. Also, researchers in clinical labs use crystal violet to stain their cells. And while the color is very nice, it also has antibacterial, antifungal and many anti-other properties, which means that if you get sick and you're allergic to penicillin, crystal violet might save your life. Now you might think that this is a commercial for crystal violet, but while we really like the dye, it actually has a major disadvantage. It's pretty susceptible to light. Meaning, if I put this vial or this piece of silk in the window, slowly but steadily the colors will start to fade. Well, what does it matter, right? 99% of your written notes are probably irrelevant after such a long time. And if you have a printed document that has been completely faded, you reprint it again. But there are moments where it does pose problems. For example, in drawings of Van Gogh, the complete picture has faded. And that jar of crystal violet used in the medical lab to detect the disease that you're coming down with must certainly not be degraded yet. To be one step ahead, we as scientists want to know what's going on in this light degradation. So what we then normally do is we take a piece of silk, we dye it with crystal violet, and we put it under a lamp or behind a window. And we wait for months or weeks for it to degrade. So once it has been degraded, we need to extract the colorant, so the crystal violet and its degradation products, from this piece of silk to a liquid sample, so that we can analyze it with our machines. Well, this extraction procedure is pretty difficult and pretty tedious. And if I would do it, I would get slightly different results than if my colleague would do it, which is obviously a big problem. So we decided to build our own system that doesn't have this problem, and that uses liquid samples. And the nice thing about this system is that it doesn't only analyze the crystal violet, but also the degradation products, which are the products that are left when crystal violet is gone. But then another problem appears. Does the degradation in this vial behave exactly the same as the crystal violet degradation that's happening on the silk? And if I would put it under a lamp, would we get the same results as if we would put it under the sun? We were racking our brain over this as well, and we decided to write a paper about it. Biggest conclusions? How crystal violet degrades does not depend on whether it was in solution or on silk. And how fast it degrades actually depends on the light source that you use. And our system was the fastest of all and can analyze all possible dyes in solution. If you're interested in the paper, go check it out with the link below, and if you have any questions, let me know. We'll hope to get back to you, and we'll see you at the next one. Bye!